Well, good evening. Welcome back to another edition of Chew Digest Diary. I wanted to talk to you guys today a little bit about something called oxalate and what it means to me. It, but I'll get to that a little bit later. I wanted to share a little bit more with you about what's been going on in my daily life. I get out every morning and I do a 4 mile walk. Today it was actually more like 5.3 miles. Um, and I got up this morning and I asked ChatGPT, based on our prior conversations, do you have any suggestion about what I should talk about today on my YouTube video? And anything I should be thinking about while I'm out doing my walking. And it gave me some great ideas. And so that's what I'm here to share with you. My thought for the day, I would sum it up like this. I'm asking myself the question, am I biohacking or am I just stretching dramatically in my living room? And I've started asking these questions on a daily basis, or these little cute posts I'm putting on Facebook, because, you know, I don't want to take myself too seriously. And I think from time to time, no matter how hard we try not to, we just, we are, for good, for bad, for worse, for ugly, for whatever. And I don't want to be that way. And so as I was walking around, I asked, one of the first suggestion ChatGPT gave to me based on our prior conversations was this idea of movement as medicine or movement as maintenance versus movement as maintenance. And what is it we're doing when we go to the gym, for example? What is it we're doing when we go out for a walk? What is it we're doing when we start stretching and do these things that we want to be doing every day so that we don't grow old without grace? Why is it important to do things like reach up as high as you can with both arms each day? My reason for doing it is because I want to be able to reach up to the top shelf and grab a can of beans, for example. I don't want to have to be dependent on one of those little grabber hook things to get something out of the top shelf for me when I get to be 119 years old. I want to fully be able to be that guy that's not dependent on a wheelchair, a walker, or any kind of aids if I can avoid it at all possible. And so pardon me, I just had some dinner. And one of the things I noticed as I was out walking this morning is I was paying attention to how my body was feeling from minute to minute, and how things would change, how it only takes me now just a real quick, maybe one block before my body is warmed up and it's fully in shape and I can just engage with my walks. And the question is, is my exercising, is my walking an exercise in exercising, or is it about fluid circulation? And I say that because our body is in one way, it's a body of water. It's like a lake. It's like an ocean, if you will. Something like, depending on our age, it can vary anywhere from like 65 down to 55% of our weight by mass is water. It's fluid. It's H2O. And so in that sense, you want to keep your body as fluid in nature as possible. And that the idea of what we're doing when we get outside and we exercise, and when we do our exercise movements, our fluid movements, if you will, that we are basically keeping our body of water from becoming stagnant. One way to look at that would be like a lake. If you're living somewhere where you've seen a lake that does not have an active head of water running into it and an active stream running out of it, you'll know what I'm talking about. Moss will build up versus having clean water that you can generally drink from. I mean, obviously, it's probably pretty smart to, if you're going to be out in the wilderness and walking around and, drinking water from streams, to get one of those bottles that filters out all the bad stuff, or even just keep some liquid iodine with you so that you can cleanse that water of anything parasitic, because you don't want parasites. But along with keeping our body fluid in its circulation, we also want to make sure that we're getting the lymphatic movement that we need to keep running throughout our lymphatic system. We have a circulatory system that the flow is directed by the heart. And that is a system that just keeps circulating from one end of the capillary beds to the other. You have these capillary beds that meet in the middle that are so fine. I'm covering my face. These capillary beds that meet in the middle, that the capillaries are so small that the red blood cells have to fold in half to make their way through, to go from being in an arterial blood flow to coming out the other side being a venous blood flow. And what happens in between that is that there is, in a sense, a deoxygenization, if that's the right way to say it, of that blood, because the oxygen is going out into our soft tissues to do its work along with our cells. And what continues on back to the heart is, I'm not so sure it's deoxygenated blood so much as it has been modified by the carbon dioxide that is a byproduct of cellular metabolism at the mitochondrial level. That's a word. That's a mouthful. And so what you're also going to experience in that process is hydration of your fascia, depending on how you say it, which is basically all of the connective tissue that runs throughout all of your soft tissues, that holds everything together and holds everything in place. That as we age, it takes on a different stage of life. But if you're not familiar with what fascia is, if you've ever had chicken, fried chicken or baked chicken or whatever, when you remove the skin, there's like that thin layer of whatever. That's fascia, and that's what's in between the outer skin and the muscle of the chicken. And in a sense, it's kind of like a lubricating layer, but it's also what encases all of our muscle fibers and holds all of our organs in place. And so it's very, very important that we take good care of our fascia. We don't want it getting old. We want to make sure we can keep it healthy enough so it can keep defying gravity as long as possible. I mean, think about even starting to hang upside down with one of those teeter hang-ups. So along with fluid circulation, lymphatic movement, fascia hydration, you also have the fluid moving throughout your body that carries what you'd call metabolic signaling, things like uh, like we spoke about yesterday, the electrolytes. Your fluid that's moving throughout your body transports the electrolytes to where they need to be so that they can do the work and help all of your cells function properly. And there's no way of getting around it. We need to make sure we have all of the right amount of electrolytes in our body, in the right amounts, but in the right places as well. And don't get me wrong, yesterday I said you can take in excess electrolytes and you'll just pee them out. Well, if you get too much magnesium or the wrong kind, it could also make you have to run to the restroom for the other kind of bathroom visit. But to wrap up this train of thought, this first train of thought, basically the idea is that our body is a body that is a hydraulic system, and that this is a natural extension of the fluid world that we live in. We are an extension of Earth. We are, in a sense, you know, the life that is happening in every handful of dirt that we pick up from below our feet. But we are fortunate enough to have been able to get up and walk around, unlike so many of the other things that are living on Earth that are planted with roots. We get to walk, we get to travel, we get to run, we can even fly. That's wild. Anyways, so on to step number two. I brought up yesterday the idea of electrolytes and how they affect fluid retention as well as circulation. And I was ruminating on that as well today. And that, in the past, I have noticed, and this is what ultimately led me to start getting out and doing a lot more walking, is that I started having issues with fluid retention in my lower limbs because I do a lot of sitting for my work and my school work, and how important it is that we use walking as a way to get the fluids back up out of our legs and back into circulation. Like I mentioned to you, we have this circulatory system that on one side is made up of arteries that go down all the way down to arterioles and into these capillary beds. On one side you have the arteries, on the other side you have the veins. Well, then there's a third system here that's our lymphatic system, but it's not connected with that circulatory system. And so how does that lymphatic fluid get back to where it needs to go? And that lymphatic fluid has to go back into our circulation, and it goes through what's called the Virchow's node, which is right about here. And right below this area right here is this huge old vein that comes back down from our lower body, and it dumps right back into the heart, right here into the just this last spring I had anatomy and physiology, and I had to memorize all the different parts of the heart, and I had to dissect a pig heart, and that was fascinating. I kind of thought about, I wasn't sure I wanted to do it, but once I got into it, it was pretty darn cool. And so anyways, our lymphatic fluid dumps right back into the left side of our heart. It then it runs through and it comes back out the right side of our heart and goes right into our lungs. And then our lungs remove the carbon dioxide from the carbon from our blood, the carbonic acid, and it joins it with the oxygen that we draw in when we take a breath. And then when we exhale, we exhale carbon dioxide. We breathe in oxygen, about 20% oxygen, 80% nitrogen, and a little bit of other stuff. And so your lungs are continually going through this process where we bring in oxygen to take out carbon. We bring in oxygen and nitrogen, we exhale CO2. And the way that works is, and the reason why I mentioned, I got out and I started walking 3, 4, 5 miles a day is because I was starting to retain fluids in my lower legs and my feet. And for those of you that have to deal with edema, you know it's not comfortable. And it took a while, but I finally got my feet back to looking normal. And one of the things I also had to do to accomplish that was I had to increase my protein intake. I found out that I figured out that my protein intake was a little bit too low. And as a result, it was probably compromising the tissues of my arteries, which was then not properly allowing for the circulation to take place and for more fluids to be able to pool down in my lower limbs. Now, the reason for the walking is because when you're out walking, with each and every step you take, your calves actually act as basically like two more hearts down in the bottom of your legs that pumps the lymphatic fluid back up out of your lower limbs and back into circulation so that it can get back into your heart so that it can continue its way through the circulatory pathways. And the neat part about all that is that, you know, as you have the capillaries that start off, you know, your lymphatic system basically starts off with a third set of capillaries, aside from your arterial capillaries and your venous capillaries. And the capillaries that make up your lymphatic system, they actually have like little, I guess you would say, holes in the sides. And through the pressure of our movement, and that's why movement exercises and movement as maintenance is so important, is because that's what pushes the fluid into our lymphatic system. And then every so often, like say in your hands, you know, if you have the lymphatic anyways, the beginning of where your lymphatic system, you know, your lymph capillaries begin, they work their way to a lymph node, like say in your hand, okay, or further up your arm and further up your arm. And let's say if you were able to trace one of these lymphatic branches all the way from like your fingertip all the way up through your arm, through here, and then into the left Virchow's node, is that you have a series of nodes that contain lymphocytes. And each one of those lymph nodes are kind of like a tiny digestive tract, if you will, in that anything that was picked up distal to the that lymph node, you know, in other words, on the far side of the lymph node before it starts heading back closer to your heart, which would be considered proximal. So like if you have a lymph node here, this side is distal, this side of it is proximal. I think that's how that goes. Anyways, I'll let you know if I need to correct that. But anyways, let's say that lymph node is right here. What ends up happening is as that lymphatic fluid starts picking up the lymphatic fluids or the interstitial fluids that are inside, you know, outside of the cells, the extracellular fluid, that you know, all of your cells, they have a life span, and when they die, there's enzymes inside these cells that are released that then break down the cells, the cell walls, and it becomes cellular debris. That's what your lymphatic system picks back up to take back to the first lymph node, where the lymphocytes consume that junk, and then their waste product becomes the fluid that moves its way back up to the next lymph node and and that's what keeps running all the way through back to your heart. And so if you ever run into a situation where you actually have a lymph node that's swollen, don't panic. That's what's happening is exactly what's supposed to be happening. It's filling up with lymphocytes because it's working overtime. And so it's just like any other operation, like if you look at a refinery when they do a turnover and they're fixing, repairing, or replacing process equipment, they have to shut everything down and they have to go to work, and they have all these electricians and welders and pipe fitters and all these different people, general laborers, that come together and they work together to get the system running and back up to speed, and then everything goes back to normal. And like, in that case, your lymphatic system will just drain back into your bloodstream and go back to normal, and everything's, like I said, just back to business. And I'm at a point right now where I think I might be splitting this up into a couple days. But first, before I do that, I do want to address the main issue of what I came here to talk to you about today, and that is, what is oxalate? Because myself, I found out a little over a year ago that I was dealing with some health problems that were related to, and I wasn't even aware that I had this issue going on. And it was a book that was recommended to me by my sister. It's called Toxic Superfoods by Sally Norton, or maybe I might have heard about it from a podcast or an interview on YouTube or whatever. I'm not sure. My sister had read this book a couple of years ago herself, and I had heard about oxalate previously, but I had never really looked into it very far. And I guess the way to describe it, and I'm actually just going to read this off script to you because it was a little bit too much to remember off the top of my head. And that is that oxalate is a naturally occurring compound found in many plants. It's a defense molecule plants use to protect themselves from being eaten. Yeah, that's right. Plants don't want to be eaten any more than animals want to be eaten. And so plants, since they can't exactly pull up their roots and run, a lot of plants produce what's called oxalate. Some of them produce other phytochemicals that are used to be offensive to other bacteria, yeast, fungi, all manner of microorganisms, as well as other animals. Think about garlic, the pungency of garlic and onions and leeks. There's a reason why they smell like that and why they're actually quite offensive to a lot of people, because that's how they protect themselves against predation. And oxalate is another one of those things. And so oxalate, again, like I said, is a naturally occurring compound found in many plants. It is a defense molecule plants use to protect themselves from being eaten. When we consume it, oxalate can bind with minerals like calcium and form microscopic crystals. In small amounts, the body can eliminate these crystals through urine and stool, But when intake exceeds what the body can clear, which frankly is not that much, it's something like maybe 50 milligrams per day, or when gut health, hydration, or mineral balance is compromised, oxalate can begin accumulating. And when it accumulates, it does so by accumulating in our soft tissues. And that's how we end up with kidney stones. We end up with a lot of skin disorders, and the uh, and we end up with skin problems that are called things like cutaneous calcinosis. Well, the question is, how does that how do those soft tissues and how does that skin become impacted by calcium? And I'm going to suggest it's through the binding of these oxalates in our fluids that then further bind with the calcium, magnesium, and the iron to form these microcrystals that then get lodged in our skin's soft tissues. And if they get to be an irritant in our soft tissues, well, then our body has these white blood cells that mature into things like what they call phagocytes that then come along, and if they can't consume whatever it is, they just simply engulf it, and our body then now has this thing that's actively like a pearl, where it is a calcium oxalate crystal that has now been enveloped by uh, proteins and lipids that then hold it in place so that our immune system doesn't recognize it as something harmful. Well, imagine that happening now over 10, 20, 30, 40, 50 years. And now you have a body filled with this stuff. And, over time, these crystals can contribute to things like kidney stones, joint irritation, soft tissue depositions, and they even may interfere with mineral availability. Think of it less like a toxin and more like a substance that becomes problematic when exposure is high. This is why some people choose to limit high oxalate foods. And it's not about fear of plants, it's about managing total load, supporting mineral balance, and maintaining fluid movement and elimination pathways. For someone thinking long term about tissue health and mobility, the question shouldn't be, is oxalate bad? It's, how much is it my body is carrying, and how efficiently can I clear it? And that's where awareness, hydration, movement, and dietary balance comes in. And I imagine some of you at this point are wondering what kind of foods contain oxalate. Well, I can tell you right now that uh, it's honestly mostly what people consider superfoods, super healthy foods. Things like spinach, sweet potatoes, almonds, dark chocolate, right? Think about the dark chocolate with almonds you eat. Right. Uh, potatoes, and a lot of other vegetables all contain oxalates to one degree to another. A lot of beans, most beans contain oxalate. Nuts, seeds, a lot of oxalate. Kiwis, a lot of oxalate. And so the reality is our body can only process through about 40 to 50 milligrams of oxalate per day. And if you're consuming fruit that has vitamin C in it, well, guess what? Your body converts the vitamin C is a precursor to oxalate. So your body already has a preset limit on how much oxalate it can process out, and that's likely based on the amount of vitamin C that our body needs to function properly anyways. So when you start doing things like thinking you're eating super healthy by eating spinach, sweet potatoes, dark chocolate, almonds, a lot of the other nuts. Matter of fact, the only nut that doesn't have a high level of oxalate is macadamia nuts, and those things are expensive. But there are, it's nothing to be afraid of. There are ways that you can eat that will eliminate the oxalate from your diet, and that it's not an easy thing to do. And if you have an ideology that you hold steadfast to that does not allow you to eat animal-based foods, you're going to have a harder time accomplishing a diet that's low in oxalate. And so at this point, I'm going to go ahead and wrap up for today, but I think I will be talking tomorrow about what is oxalate part 2, because I really want to lean into this a little bit more, but also talk to you more about the difference between health and longevity readiness. So we'll talk about that tomorrow. And walking as cognitive integration, how our cognitive abilities are affected by things like walking, and how it affects lymphatic flow, cerebral blood flow, and even creative insight. And then I can wrap up on the question of what is oxalate, and we'll talk about that more late as time comes, because I will want to interview some people on that topic, because this is something that people really need to wrap their heads around, because most people will find that even most of their doctors are not very aware of this, but in the very near future, that's going to be changing. And there are people like me that hope to be that one of those catalysts that make that happen. So anyways, I just wanted to cover all that with you for today. It's been now 31 minutes I've had this thing running, and I will check out for the evening. I'm not sure what I'm going to eat. I already did have a little bit of dinner, pre-video dinner. I'm going to go have some post-video dinner, and I will talk to you guys later. I'll see you tomorrow. Checking out. Mike Loomis here with you on Chew Digest Diary.